Hey guys, it's Logan again. Welcome back to another video on creating a Spelunky-like level generator in Gamemaker Studio. So in the previous video, we made our lists and we stored our strings that represent our rooms or our different sections of our rooms in memory, and we stored them in a list. So the next thing we need to do is actually start building our level using these strings. And we can build our random map since we have our create main path finished. So we have our main path that our room needs to follow. We just load in the corresponding sections that those areas need. So the first thing that we're going to do, sorry, I had to open up my other project. I'm gonna go ahead and close all these down. Okay, we have our initialize room. Let's go back to our initialize room script. Okay, so we kind of laid out what we needed to happen using our comments earlier. So we needed to create our main path, which we did, and this is just a debug message here. We could actually delete it if you would like, but I like to see exactly how my layout is being made each time we run the game. And now we need to initialize our sections, which we already wrote the code for. So under the initialize our sections, I'm just going to write initialize all sections, and that's going to basically load in those strings into our various lists. And then we need to create our level. And we're gonna use a script called create level that we haven't, or let's say generate level. Generate level, that makes more sense. Generate level. And we need to clean up our memory, so let's actually just destroy our lists for now. Let's do ds_list.destroy. This is because once these lists are created, since they're created dynamically, we need to be able to go through after we're finished and clear all that memory out that's being occupied by those strings. And if we don't do that, then it could lead to memory leaks, which are basically each time we run the game, more and more strings get stored in our memory, but that memory is never cleared back up for our computer to reuse. So let's go ahead and destroy our lists, and this is going to go through, like I said, and clear out all those string values from our memory when we call this. And we actually want that to happen after our room's generated, so that we aren't using that memory, because we aren't ever going to use these lists again after we create our room, unless we were to make a new room and then we just recreate the list. It's not a big deal. So what are our list names? We have, I even forgot. So section left, bottom, right list. I just selected that from IntelliSense. And we have 3 of them, remember? So we have ds list destroy section left right list. And one more, ds list destroy section top left top right list. And now our memory is cleaned up. So the last thing we have to do is generate our level. So let's make a new script and call it generate level. Create generate level. So I made a new script. I'm going to put it under our our create main path script. And let's do, I guess I'll kind of explain what needs to happen here. So the first thing that needs to happen is that we need to create the border for our room. Because remember, our entire room is going to be surrounded by blocks, right? We don't want to have an empty area on the outside. And okay, so you can see that we have this solid block along the outside of our room, and we'll go ahead and create that first. And this is pretty easy to do. We just use a for loop for, let's say I equals 0. Actually, let's put this like that. I equals 0. I is less than room width. We're gonna just cycle through our grid divided by grid size. Remember, we have that stored. And we're gonna increase our I at the end of our loop. So now we're just gonna cycle through each grid space along our room width, along our x-axis. And we'll just create an instance in that grid space at the top of our map and one at the bottom as well. So we'll do instance create not depth, layer If you're in an older version of Gamemaker, you don't have to use layer. And where are we going to create it? We're going to create it at our current I times our grid size. We could actually do room width and plus equal 32. It might actually, I haven't tried this yet, but in theory it should work. Let's actually delete the grid size. And instead of plus plus, we're going to use plus equal grid size. And this is going to increase our basically X by 32 each step. So yeah, let's try this. It should work in theory. So we're going to increase that at the current I position and at 0 for Y. So at the top of our room. And what are we creating? We're creating, well, we have to pick the layer we're creating it on, which is just our default instances layer. And we're creating O block. That's why we named it, yep. And then let's create, I'm going to copy and paste this line. We're going to do the same thing, but we're going to create it on the bottom of our map. So we're just going to use room height minus grid size for our Y value. Room height minus grid size. And that's our Y value. And this should give us, if I hit, I got to rearrange our rooms. Put our level generator up top here. And if I run the game, which I haven't ran in a while, so hopefully there's no bugs. Okay, you see it puts blocks along the top and bottom of our room. We just need to do that same thing for the left and right side, which you can see by this visualization, we don't want to create it at this top left or the bottom left. Same with the top right or bottom right, because that's already been created. So we can kind of get around that. We don't want to put another object on top of those. So we'll copy and paste our loop. I just copy and pasted the entire loop. And we're going to use room height, but we don't want to go the complete height because we don't want to place it at the bottom left, like I just said, because there's already a block there. So we're going to subtract grid size from that room height. But remember, we also don't want to get the top left part. So we're going to start at our grid size. So we're going to set I equal to grid size to start with, and then we're going to go down until I is, as long as I is less than our room height minus grid size. So what that does is, for example, this is kind of hard to explain, but we have this block up here. We're skipping that by adding a grid size to our initialization variable. And then we're moving down until we are at the bottom, the one up from the bottom left. And I guess I'm not going to explain that any better. So hopefully that makes some sense to you. That's why we started at grid size and went to our room height. And the second thing we need to change is the X value, because remember we're going vertically. We want to set our X for our first one to 0, and then our Y value is going to be underscore I in this case. And the same with the one under it. We're going to start at room width minus grid size, and we're going to have our Y value be the same, underscore I. Okay, I'll give you a second to pause and copy that if you need it, and I'm going to run it again, and we should see our walls generated now. So we have a border around our room to place our rooms inside. So now we need to start placing our different sections in here, right? 4 across, 4 down. And we already have our main path that is generated that we'll use to pick our templates. Where do we need to start? If we start at 0, 0 to be placing our sections, then we're going to have this weird thing where we're going to have a space down here along the border, and then it's going to kind of, our sections are going to overlap this border. So we need to have kind of an offset that we start our sections at, which is going to be grid size and grid size along the X and Y. So that's going to start us in this upper corner and then place our rooms. This is why we made our room width have an extra 32 pixels on both sides. That's why we did grid size times 2 onto our room width to account for this extra space that we needed. Okay, so let's go ahead and comment this in. Generate border for room. And in your actual game, if you didn't want these objects to be able to be destroyed along the border, you would use like an O block permanent object that isn't allowed to be destroyed. It would just be a solid object that you could never go past. So that you just replace O block, that with O block. Okay, so next we have our border. And like I said, we need to have an offset. And secondly, we need to keep track of where we are placing our rooms. Okay, so what do I mean by that? Well, we're going to start in this upper left corner, right? And we're going to place a section. We're going to load in a string and place in all those blocks. And then we're going to move up, kind of like we did with current X and current Y when we created our algorithm to make our main path. We need to keep track of what grid space we're in and place our objects in accordance to that grid space. So hopefully I didn't just tell you wrong, because I looked over at my code and I don't even think this was actually used. But in theory, that's how it would work, right? So let's go ahead and create a new variable. We'll call var section string data. And we're just going to initialize it to an empty string to start out with. This is going to house the string that we pull in from our room section generator scripts that we stored. So we're going to pull in a value from one of those DS lists and store it here. Then we're going to cycle through each character in that string and place the according object in the correct areas in the room. So let's use a couple variables. We use for underscore y equals 0. Underscore y is less than room. Let's say x rooms, because we remember, didn't we set that in our initialized room? X sections, not rooms. So it's going to be X sections. Wait, this would be Y sections, wouldn't it? Y sections, yeah. Y sections, and then Y underscore Y plus plus. Okay. Oops, I got this extra. There we go. So we're going to cycle through all of our Y values, but in between each cycling of the Y, we're going to cycle through all the X values. So let's do the same things. For underscore X equals 0. Underscore X is less than X sections. And then underscore X plus plus. We're going to add 1. Alrighty. So next, let's load in, I guess, a random string from one of these different scripts that we have. We need to load in a random string corresponding with what value that room contains, or that section contains. So what we'll do is we'll say section string data equals, and we'll create a script called load random section. Load random section, okay? And what we're gonna pass into that load random section is the type of room that we need to choose from, the type of template that we want. And remember, in our initialized room, in our create main path script, we set our sections array to house these different types of values. That's what gets compiled down here. These are our different sections that we need to choose from. So 1 is the LR sections, 2 is the LBR sections, and 3 is the LTR sections. So all we need to do is pass in our section variable. So our section array. So we're going to pass in our section array, and we're going to pass in our sections array at the index of our X and our Y. So that's going to pull the value from what we created earlier in our initialize, in our generate level, or create main path. Sorry, I'm all over the place. So like right here, we set some index inside of section to 3 right here, right? So that would be the top room. So basically all we're doing is grabbing the value from that specific position and seeing, does it equal 1, 2, 3, or 0? Okay. And that is what we're going to pass into our load random section script. Okay, so let's go ahead and create that script. Create a new script and call it load random section. And remember, we passed in a value, so we can grab that value that we passed in by using the argument keyword. So we're going to say section type equals argument 0. And that's going to set section type to equal that value that we just passed in. So section type will equal this, whatever this is. Okay? All right. Grab section type from sections array. That's what that does. All right, and then the next thing we want to do is create our switch. So we're gonna do switch section type. Remember, this is kind of like an if then statement. So we're saying if section type equals, well, in case 1, if our section type equals 1, that means we need to load a LR room or a left-right room. All we do is return a value, because remember, we're returning a value, so that's why we could say this equals whatever this is going to return. So we're going to return a value to assign to this. So we're going to return a string, obviously, and that string is going to be from our lists that we made, one of the random lists. So we'll pick a random value from this list. We can use dslist.findValue. What findValue does in a dslist function is that we say what list we want to look in. So since it's case 1, we want to look in our sections section left right list. That's the list that we want to grab a value from, since it's type 1. And then we're going to grab the second parameter in the dslist find value function. Says what position do you want to grab that from. So right now we just have 0 and 1. Basically the 0 position's that first string that we saved in our list, and 1 is the second string. But as you add more strings, we want it to, you don't want to have to come in here and change code. So we're just going to use a random function. We're going to use floor random. Remember, floor rounds down whatever value you put in here. So if we were to put 0.4 into floor, this would return 0. Or if we were to put 1.4, it would return 1 because it rounds down. Even 1.8, it would return 1 because no matter what, 1.99 would return 1 because it always rounds down. So we're going to feed it a random value between 0 and our list size, and we can return our list size by using dslist size. And what list are we checking? Well, we're checking our section left right list. I'm just going to copy paste that inside here. You're going to have quite a few parentheses, and that's going to return the size. So our size is going to be I believe 2. I think it'll be 2, but we're returning a random number in between that, and so it's going to round down. And hopefully that's right, and if that's wrong, someone tell me, because now I'm second guessing it. I feel like there's something wrong about it, but it's worked for me so far, so we'll go with it. And then we're gonna break out of the switch if we need to. I'm just gonna copy paste all that code and label it case 2, and I'm gonna copy paste it all again and label the third one case 3. Okay, so we just need to change just the name of the list that we're accessing and grabbing values from. So in case 2, we're going to grab a value from left bottom list. Left bottom right list, I believe is what I named it. Yep. And I'm going to copy paste that into the other one along this line. And then we have left top right list for our final case. Now we still have the case of 0, correct? So we could end up passing in 0 to this. So in the case that we get 0, for now, unless you have made rooms that are specifically for the type 0, this would be your shops or whatever you might randomly want to place, you would just add in another case for the 0 and do this, follow the same template as this. But if you're just following along with this tutorial, I'm going to do if section type equals 0, then we're just going to pick a random number 1 through 3. So we're going to use a section type equals choose 1, 2, or 3, and it's just going to load a random one of these rooms into each of our 0 spaces. So each of these little spaces can be a 1, 2, or a 3 right now. But if you made specific rooms for a 0, then that's when you would do case 0. And that's the end of this script. That's going to choose a random section from one of these scripts. So it's going to choose one of these values randomly, and it's going to return that long string to our variable right here. Okay, so now we have our string. Now we need to actually create that string in our room, or create that map from that string in our room. So we're going to just use a script called create section from string. And we're going to give it an XY value. Which section are we generating? Either 0, 1, or 0, 0, 0, or 0, 0, 1, 0, 2, 0, 3, 0, or go down to 0, 1, 0, or 1, 1, you know, the grid. It's the grid. Should I close my PowerPoint? Okay, so basically, which one of these rooms are we currently building a map for? That's what we're passing in. So we're going to pass in our _x again and our _y, because that's our current section that we're building our map in. And then we're going to pass in our string. So our section string data that we just randomly grabbed, right? Okay, and this is going to be the end of it. After this, we're going to have a full room. We just need to make our create section from string script. So let's add a new script and call it create section from string. And I'm going to move this up to under generate level. So we have our different folders. Load random section. I'm going to move up right above that. Okay, so we have our create section from string. Okay, so let's set a couple variables. First of all, let's set our var. I'm using var, so this memory is deallocated after the script executes. We're going to say current x section equals arguments 0. Remember, that's that x value we passed in. That's going to be our current section that we're working on. We're going to do the same thing for y. Current y section equals argument 1. And then var chunk. We'll do section string data, and it equals arguments 2. And you'll see that I'm using a underscore just in case we named, because I feel like that's a name that we used previously. So using the underscore kind of ensures that we're not using the same variable name, which honestly probably wouldn't cause a huge issue right here because it would set it equal to itself. But yeah. Okay, so now we just need to use a for loop. So for, we're going to cycle through our string at this point, right? So to create our map, before to decode it, we cycled through the objects in our section and encoded those objects as a string value. Now we're going to do the reverse. We're going to cycle through each character in the string, and for whatever that character is, we're going to place an object corresponding to it. So we're going to use I'm going to use C for character equals 0. C is less than string length, which is going to return how many characters are in that string. And what string are we checking? Well, section string data is the string that we passed in. And then we're going to use C++. Well, we're not going to use C++, but we're going to use C++ to increase our C value. All right, and now we're just going to do another switch statement. So we're going to do a switch, and we're going to use string character at. That's going to grab the actual character at a specific position within that long string, so one individual character. And what string are we checking a character for? Section string data once more. And what position? Well, that's just our C. That's what we're cycling. We're just increasing the C each step and going through our string until this condition is no longer met. So we're at the end of our string, and then we're done with the loop. Awesome. So now we just need to do our cases, okay? And let's say for the case 0, so the case that this returns the value 0, we're just going to break, okay? Because we don't want to place an object at that position, right? So we just are breaking out. And then we're going to use case 1, and that's going to be our blocks. So we're going to use instance create. We need to create a layer, create in a layer in Gamemaker Studio 2. And we're going to be creating at our current X section times chunk width. I'm going to try to explain this math as much as I can. Okay, so we know, or it's not chunk width, it's section width for us. So if I pull this up, we have a section width that is this entire width in pixels for one section. So we can multiply what room we're in by that amount to get basically our starting point. So if you were placing a block here, this is section X, along the X axis is 0, then it would place this object at this point. But if we were to move over a section, so we're multiplying by 1, we want to have our entire chunk width times 1, which is going to move us here. If we're in this section, then we have our chunk width, which is this width, multiplied by 2, which is going to start us here, multiplied by 3, it's going to start us here. And I hope that makes a little bit of sense. So that's why we're multiplying our current X section, which is going to be 0 through 3, and multiplying that by our section width. That's going to be our very starting block point. And then we're also going to do, let's see, yeah, I'm in the right spot. We're going to add on the actual position that we need to be in. So what I mean by that is we got our starting position, right? But that's all we have. We need to be able to tell which of these little grid spaces in after that starting section we need to place the individual block. And we can do this since we know that our what do you call it? We have 10 tiles wide. We can use the mod function to make sure it's only 0 through 10 always. So what mod does is returns, this is hard to explain. So what mod does is return the value, maybe it's better to explain it with an example. Actually, documentation might clear it up for me. So we're gonna write cmod 10, and hopefully this has a better description than I can think of right now. So let's see, mod. Okay, so we're div, blah, blah. Mod gives you only the remainder of a division. So for example, if you were to have 11 mod 10, that would return 1, right? And that's exactly what we want to happen. Let's say we count over 10, 1, 2, 3, 4, 5, 6, 7, 8. Okay, I didn't count good enough. But let's say this is the 10th position. Then we want to restart back at 1 on the x-axis, right? So when it hits 11, the 11th character in the string, which would be here, it actually returns a 1. And it's going to do this until you get to 20, and then it's going to try 21. It's going to return 1 again. So it's going to return 1 once it gets past that 10 point. So we're actually going to use a variable, what was the, section tiles x is what we're going to use there instead of 10, because we could have more section tiles. So right here, we're going to do 10, or we're going to use cmod, because remember, C is the actual value we're placing. Mod section tiles x. And not only that, we need to multiply this value by our grid size, which is going to be 32 at the moment. And this, again, is going to skip by 32 pixels. So 1 through 10 is only going to move us 10 pixels. But we multiply each one of those values by 32, and it's going to move us 32 pixels at a time. Okay, so I know that's a lot of math for one X position that we want to place our object in. We actually need to add one more thing, and that is our grid size. And again, our grid size is added because we have this offset right here. So we need to add that 32 on to whatever value we have before that to make sure that we skip that 32 pixels at the beginning of our room, okay? Now we need to do kind of the same thing for Y, okay? And I'm gonna go ahead and hit enter after my comma to level this out. This is gonna be a little bit different because we aren't gonna be using mod for this one. So what we could do here is use underscore current. Remember, we're working on our Y now. Y section times chunk, or section height. That's basically doing the same thing for us as before, and I'm gonna put this inside parentheses. Did I put all these in the right parentheses? Yes. Okay. So we have current Y section times our section height, and then we're gonna add, instead of doing our mod this time, we're gonna use the floor inside of parentheses, floor of C divided by 10. And we're gonna multiply that by grid size like before, and then we are going to add our grid size to get that offset from the beginning, right? And then I'll explain this in a second. And what layer are we creating that on? Oh, I need to increase my font size. Sorry, guys. So I'm going to do another enter. And we're creating it on the instances layer. And what are we creating in the case of a 1? Just O block. Okay. And here I have parentheses messed up somewhere in this. So current. Okay, I just had one too many there. Okay, so why are we using floor C divided by 10? Remember, C is going to be 0 through 80, basically, because we have 80 characters in our string at this size. So with that being said, we're not actually going to use 10, we're going to use grid size. Or is it section? It'd be section tiles X here as well. C divided by section tiles X. So what this does is our character value gets to 11, right? Okay. Then we need to increase our Y. So we do 11 divided by how many tiles wide there are, which are 10. What's 11 divided by 10? Well, it's 1.1. So in that case, we divide it out so we get 1.1, and then we get the floor of that, which equals 1, which is going to move us down. So 0 divided by 10 is 0. 1 divided by 10 is 0.1. We get the floor. It sets it back to 0. Then we go up to 0.2. Get the floor, sets it to 0, so we're always along this space, along the y-axis, until we get to 11, in which case our floor returns us a 1. Get to 21, our floor returns us as a 2, and we're moving down 1 by 1 in our vertical axis. I know the math's kind of hard to understand here, but it works. All right, and instead of rewriting all that, I'm just going to copy paste the entire case, and we're going to do, we haven't made any other objects, but I'll show you how to incorporate more objects in the next video, but for now, if you had like a ladder, you would replace this with whatever character stood for the ladder, and then you would just replace O block with O ladder, and that's it. You do that for each object you have. No big deal. Copy and paste. And then we're gonna break out of the loop after this, and we are done. So as long as we set this up right, we have generate level, destroy our lists, generate level. Let's go into that script. It creates our border, creates our new section. It gets a string from randomly selecting a section. Then it creates a section from the string, which grabs our values with our arguments and goes through our entire string character by character, placing objects in correspondence to what our string values are. So if I hit play now, hopefully, there we go. We have a random room, and you can see how it's actually placed. Down here, it starts at this 1 point, so it starts in this room actually, and you have a complete pathway all the way through your level. And again, there's not a lot of variation. We only have 2 templates for each type of room. So you're going to see a lot, and plus our 0 rooms are selecting from the random 6 templates also out of all 3. So now you have your random pathway. If we were to generate again, then you could see it's almost reversed. We have our random pathway this way with even like a room that we could go off into. This could be a shop or something. This one could be a shop or something, but our end point, our end room would be here. Awesome. So I hope that tutorial helped a little bit, and I hope it made at least a tiny bit of sense. And this video is going to take forever to render. I'm sorry these videos are so long. I try to explain as best as I can. Really try to understand what this math is doing. Remember, we're cycling through our string 1 character at a time. Our string is 80 characters long, so we need to translate that 80 characters into, if we're moving along the x-axis, it needs to be 0 through 9, 0 through 10, whatever it is. And then if we are moving vertically, we need to translate that 80 characters into 0 through 8, because we only have 10 spots horizontally, 10 grid spaces horizontally, and 8 grid spaces vertically. Awesome. So I hope that helped, and if you enjoyed it, please like and subscribe. And in the next video, we'll implement some more stuff, maybe some random chunks, and I'll come up with some more stuff to implement. I hope this video helped. Thank you for watching. Please like and subscribe, and I'll see you later.